So let's talk about something that every great programmer does before they even think about writing a single line of code. They make a plan. You wouldn't build a house without a blueprint, right? Well, it's the exact same idea for building software. Let's dive in.
And to kick things off, a quick question for you. What is the very first step to building a new app? Now, if your first thought is fire up the code editor, well, not quite. The real first step happens way before that, usually just in your head or on a piece of paper. It's all about the plan.
And that's our big idea today, the programmer's blueprints. Just like a builder needs a detailed plan to avoid chaos, a programmer needs a clear strategy. Trust me, this planning phase saves you from so many headaches later on. So, let's look at the first tool we can use to get our ideas down. Okay, our first tool is all about sketching out the idea. It's called Pseudocode, and it is the perfect way to outline your logic without getting all tangled up in the strict rules and syntax of a programming language.
So what is this stuff exactly? Well, pseudocode is just a way to write out your program steps using plain, simple English. The pseudo part literally means fake, so it's fake code. There's no complex syntax to remember, no semicolons to forget. It's just a clear step-by-step description of what you want to happen.
And this is why it's so powerful. Just look at the difference here. On the left, you've got simple English anyone can understand. On the right, you've got actual Java code. Now, they both do the same thing, but the pseudocode lets you focus entirely on the logic. The if this happens, then do that, without worrying about all the specific programming rules just yet.
All right, time for a quick check-in. Based on what we've just talked about, what would you say is the main reason, the primary purpose for using pseudocode?
Exactly. The whole point is to outline your logic in plain English. It's a way to plan things out so that anyone can understand it, long before you get tangled up in the details of actual code. It's the first rough sketch in our blueprint.
So once we have our rough sketch, it's time to create a more detailed visual map. And this brings us to the next awesome tool in our blueprint, flowcharts. A flowchart basically does for your logic what a map does for a city. It's a diagram that uses a set of standard symbols to give you this amazing bird's eye view of how your program works from start to finish. You can see all the different paths and decisions it might take along the way.
And here are the basic building blocks. You've got ovals to mark the start and end. You use rectangles for any kind of process or action, like add two numbers. And the most important one, the diamond, represents a decision, a point where the program has to answer a yes or no question. Let's see how it works. We start with an oval, then a process and a rectangle, get user input. And here comes the critical part, the decision diamond. Is the input valid? This is where our path could split. But no matter which way it goes, we eventually get to the end, marked by another oval. See? Super simple, visual, and incredibly clear. Okay, let's make sure that sank in. In a flowchart, when your program needs to make a choice, which symbol do you grab to show that critical decision point? You got it. It's the diamond. Anytime you see a diamond, you know the program is at a crossroads, asking a question that will decide what it does next. It's the symbol for a fork in the road. One more, just to lock this in, take a look at the options on the screen. Which one of these shapes is the odd one out? Which one isn't part of our standard toolkit for making these flowcharts?
Yep, the triangle. Well, you might see it in some super specialized diagrams. For our blueprint, the oval, rectangle, and diamond are the fundamental shapes you need to know.
Okay, so we've got our sketch and our visual map. But a good blueprint isn't just for you. It's also for anyone else who might work on the project. That brings us to our final planning phase, making sure our work is easy for other humans to understand.
And there are two main ways we do this. First, we have comments. Think of these as little sticky notes you leave right inside your code for other developers to read. The computer just ignores them completely. Then you've got documentation. That's more like the formal user manual that explains how the finished software actually works.
And here's a perfect example of a comment. See those two forward slashes? That tells the computer, hey, just ignore everything after this on this line. But for a human reading it, that little note is gold. It explains the why behind the code, not just the what. So, with that in mind, what do you think is the single biggest reason a programmer would take the time to sprinkle these comments all through their code? It really all comes down to collaboration. The main reason is to explain the logic to your teammates, or, let's be honest, to your future self when you come back in 6 months and have no idea why you did something a certain way. Good comments are a total game changer.
So let's pull our whole blueprint together. We start with Pseudocode, our English language sketch. Then we use flowcharts for the visual map of our logic. As we code, we add comments as notes for our team. And finally, we write documentation to be the official guide for everyone. See how each piece builds on the last?
And that leads us to one last really important question. After you've laid out this beautiful, detailed blueprint, who is actually responsible for taking that plan and turning it into a real working piece of software? The answer is the programmer. You. These tools don't write the code for you. They're the plan, the guide, the map. The programmer is the skilled builder who reads that blueprint and actually brings the whole thing to life. So here's the bottom line. Good planning is what separates okay software from really great software. It turns what could be a chaotic mess into a structured, manageable project. So now that you have the tools to create the blueprint, the only question left is, what are you going to build?